Daniel Kvak is leading two doctoral research projects at Masaryk University in Brno. The first focuses on the connection between artificial intelligence and music, while the second explores research in medical imaging and its applications through AI systems. At the Speaking AIArt 2025 conference, he will present a lecture titled Visual Data and Its Processing: The Use of Artificial Intelligence and Machine Learning in the Visual Arts. This lecture will shed light on the development of AI-driven imaging in the realm of visual and other arts, offering insights from various philosophical and aesthetic perspectives on the topic.
Hello, my name is Daniel Kvak and I'm pleased to welcome you to this lecture, Visual Data and Its Processing: The Use of Artificial Intelligence and Machine Learning in Visual Arts. As the title suggests, we'll explore the intersection of visual arts and artificial intelligence, a rapidly growing field that is reshaping how we create, interpret, and interact with images. Throughout this talk, we'll examine how AI-driven models process visual data, generate new artistic content, and challenge our traditional notions of creativity and authorship. I'd like to begin with a brief introduction. I hold a master's degree in interactive media theory, where my thesis focuses on using generative models, LSTM neural networks, for the automated generation of musical composition. Currently, I'm completing my PhD in digital culture and creative industries, where I continue to explore the role of generative AI in cultural domains, further developing the intersection of AI, creativity, and artistic expression. When we talk about visual data, what do we actually mean? Many people might think of vacation photos or family snapshots, but visual data actually goes way far beyond that. It includes a vast range of digital images, videos, or AI-generated visuals, all of which can be stored, processed, and analyzed using computational methods. In today's digitized world, visual data is basically everywhere, playing a crucial role in fields ranging from medicine to art. AI is also increasingly being used to interpret, enhance, or even create visual content. In this lecture, we'll explore how artificial intelligence can analyze, transform, and generate visual data, reshaping the way we engage with art and creativity. But for me, it actually makes sense to start at the very beginning. Imagine it's 1940 and an 18-year-old mechanic named Marcel Ravidat is walking his dog, called Robot, through the French countryside. Suddenly, Robot disappears into a small hall. Curious about what his dog had found, Marcel returns next day with a few friends to explore. What they uncover is absolutely breathtaking. A hidden cave filled with paintings of horses, deer, bison, or even extinct species like the woolly rhino. The images are remarkably detailed, painted in red, yellow, and black using the powdered mineral pigments. These ancient artists likely applied the colors by blowing the pigment through hollow bones onto the cave walls. Today, we know that these Lascaux cave paintings are at least 17,000 years old, some of the earliest known examples of visual art. They remind us that the desire to create and express ourselves visually is deeply embedded in human history and culture. But in addition to the breathtaking animal paintings, the explorers of Lascaux Cave discovered something much more personal: these human handprints. Unlike the detailed depictions of animals, these simple imprints carry a profound message. They are voices from the past silently declaring, "I was here." Each handprint is a direct, intimate connection to an artist who lived thousands of years ago, a reminder of the human need to connect, to share, and to leave a mark on the world. When we look at these paintings, we recognize the same desire for self-expression that drives us today. Whether it's a hand pressed against a cave wall or a digital artwork created using AI, the message remains the same: I was here, and this is my story. What's particularly interesting is that when generative AI surged popularity in 2022, one of the most talked issues was its struggle to generate realistic human hands. Fingers often appear distorted, fused, or unnaturally positioned, a small but noticeable flaw in AI-generated art. While this might not have a deep anthropological connection to the ancient handprints in Lascaux, it's fascinating to see how we continually face new artistic challenges with each technological advancement. Just as early humans experimented with pigments and tools, today we are navigating the quirks and limitations of the AI, refining it as we push the boundaries of creativity. The concept of artificial intelligence was once confined to science fiction, but today it is absolutely an integral part of our everyday lives. Synthetic media, let's say AI-generated images, videos, and text, are basically just one example of how AI is reshaping the modern world. The idea of AI as a true intelligence dates back to 1950 when Alan Turing introduced his famous Turing test. The test involved a conversation between a human and an unknown entity, either another human or a machine. If the human evaluator couldn't distinguish between the two, the AI was considered to have passed the test. As a formal research field, AI was born in 1956 at a workshop at Dartmouth College, laying the foundation for digital computers to be used in generative art. Over time, AI development split into two key approaches, one based on a predefined rule-based programming, and the other one on neural networks that were inspired by the workings of the brain. Though the brain itself, of course, remains a scientific mystery, studying biological intelligence has helped us, basically, to shape the modern AI. Over the years, AI has evolved beyond simple computations to include computer vision, character and face recognition, natural language processing, or machine learning directly. The field has recently reached a tipping point fueled by massive investments and the growing availability of training data. However, despite these advancements, I believe we are still only scratching the surface of AI's creative potential. Basically, what we see today is just the tip of the iceberg. When we talk about artificial intelligence, one of the most frequently mentioned terms is machine learning, the process by which algorithms learn from the data rather than being explicitly programmed for specific tasks. Instead of following fixed instruction, these algorithms analyze large data sets, identify patterns, and build models to perform tasks like prediction or classification. We are basically using the two most fundamental approaches, which are supervised and unsupervised learning. Basically, supervised learning involves training the algorithm on label data, where it learns to associate inputs with the correct outputs. On the other hand, unsupervised learning involves feeding the algorithm basically just unlabeled data, allowing it to find hidden structures or patterns on its own. Machine learning is a powerful tool that can process vast amounts of information and recognize patterns beyond human perception, and has already revolutionized fields including medicine, finance, or even visual arts, basically enabling AI to see, hear, and even create in ways that we never imagined before. If you've heard of machine learning, you've likely come across the term neural network. Artificial neural networks are computational models that are very loosely inspired by the human brain, where thousands of interconnected neurons process and transmit informations. Unlike traditional algorithms that follow the explicit instruction, neural networks actually learn independently by analyzing the amount of data and adjusting their internal structure accordingly. Neural networks improve their accuracy through a process that's called backpropagation, where errors in predictions are sent backward through the neural network to adjust the weights between the neurons. The cycle repeats until the model refines its ability to recognize patterns and make better prediction. One of the key roles is dimensionality reduction, simplifying complex data into more manageable patterns. This is particularly useful in fields like image recognition or natural language processing or just basically any data analysis. And of course, in recent years, the term deep learning has become widely popular. Deep learning refers to machine learning techniques that use deep neural networks with many layers, allowing AI to process highly complex patterns in data, leading to major advancements in newly coming fields. Convolutional neural networks process images through multiple layers, each with a specific role. The process moves from simple to complex feature extraction. At the first layers, the network detects basic elements like lines, textures, or colors, similar to how we first notice simple shapes in an image. As it goes deeper, it starts recognizing patterns and structure, like the outline of a cat's eye or ears. In the final layer, the network identifies high-level features that define objects, allowing it to recognize, for example, the cat based on its overall shape and key details. So this step-by-step process enables CNNs to classify images by gradually building on understanding of the features. ConvNet Playground is an online tool that allows us to visualize how a convolutional network sees and interprets an image in its different layers. You can play with the different images and watch the features change from simple to more complex. Basically, you move throughout the network to see the changes in the features that are extracted by the networks and so on, and visualizing the outcome of the neural network as well as the prediction process. Let's take a moment to revisit the basics of machine learning. Why is the dataset so important? If a neural network is like a student, then the dataset is its textbook. Just as quality study materials are crucial for learning, high-quality data is essential for training the AI. Powerful neural networks require a large dataset. The more data they have, the better they can recognize patterns and generalize to new, unseen inputs. One of the most well-known datasets is ImageNet, which contains over 14 million various different images. It has been the foundation for training many of today's advanced visual models, enabling them to recognize objects, detect features, and even generate new images. But here's a fun fact. The ImageNet dataset, renowned for its vast collection of images used to train the models, includes a significant number of dog images. In fact, out of its 1,000 unique class categories, 90 of them are dedicated to just different dog breeds. AIArt is a unique dataset that contains thousands of works of art from different artists, time periods, and styles. This dataset gives us the ability to train neural networks to recognize different art styles from Renaissance to modern abstract art. Thus, we not only have the ability to recognize and classify different art movements, but are also able to create new works inspired by traditional art. With the increasing availability of the datasets, such as AIArt, there is also growing interest in automatic classification of artworks. But why would we want to classify art, and how can we do it? So classifying artworks using machine learning is a ambitious task because art is deeply subjective and each image carries a unique meaning, emotion, and history. But thanks to modern techniques, we can now train the machines to recognize different aspects of artworks, such as colors, shapes, objects, or even overall style. This may found use in large museum collection, for example, or also some fun projects meanwhile. Generative models create new data based on what they've learned from existing samples. Imagine a painter who has studied hundreds of horse paintings. Without copying any single one, they can now paint a completely new horse based on their understanding. In AI, generative models work the same way. They analyze patterns, colors, and shapes from the training data, and once they learn the underlying rules, they can generate entirely new images. A fascinating aspect of these models is their ability to blend styles or create unique visuals that never existed before. This enables applications such as style transfer or anything else where the image can be reimagined in a different artistic style, or basically just generation of entirely new and original images. But before we jump on that, photo manipulation has existed long before computers with techniques like retouching, where elements are altered or removed, or collage, where multiple images are combined to create something new. One of the most difficult to detect methods was always scene manipulation, where a composition was staged before the photo was taken, making it nearly impossible to tell afterward whether it was real or deliberately arranged. Examples basically include war photos where objects like children's story were placed on the battlefields to create, for example, emotional impact. Also, very old technique is actually face swapping, where faces or body parts were replaced. For example, after Lincoln's death, the demand for his portraits was so high that engravings often placed his head on other bodies. And of course, photo manipulation was also very widely used in propaganda, particularly in Soviet Union under Stalin, so during the political purges, inconvenient figures were erased from photographs using retouching or collage, creating a false historical record. In the past, these edits were painstaking and required significant skill. Today, digital tools like Photoshop and AI-powered deepfakes have made image manipulation much more easier, faster, and more sophisticated than ever. Deep Dream was originally developed at Google and was trained on the General ImageNet dataset, which is a huge dataset of images. But what exactly does Deep Dream, as probably one of the first known generative model, is doing? So many people think of Deep Dream as a generative model because it creates fascinating and often surreal images. But the reality is a bit different. Deep Dream doesn't actually create images out of nothing. So instead, it takes an existing image and modifies it to visualize patterns that the model sees or dreams based on its training. It's like giving an artist a magnifying glass and asking them to highlight certain details, textures, or patterns they see on the canvas. So the result is a painting that is at once familiar and new, with deep and often unexpected details. Deep Dream in 2016 was actually showing us the power of neural networks in art, while also reminding us that the technology can have not only practical, but also unique aesthetical value. One such network is autoencoder, which represents a specific architecture of neural networks that finds its application mainly in generative modeling. The original idea was actually focused on not on content generation, but on a dimensionality reduction alone, with multiple augmentations to different forms of tasks have been made over the last couple of years. So the motivation behind the model is to learn a so-called identity function hidden in a latent space layer, basically as a bottleneck. As a result, the autoencoder has the ability to generalize the input data and transfer it to lower dimensional space. The error value then represents, in simplified terms, the difference between the input and output latent space. So the only features that the neural network is using for generating the new content is basically the information, the encoded data stored in the latent space. If we want to start using this neural network for generating new content, we can just basically run it with a random trigger variable, and then we talk about so-called variational autoencoder. On the other hand, generative adversarial networks, or GANs, are a breakthrough in machine learning that train two competing neural networks simultaneously. It was introduced in 2014 by Ian Goodfellow. The GANs actually use game-theoretic approach to learn the generative models. GANs consist of two main key components: the generator, which creates new content based on the training data, and the discriminator, which evaluates whether the generated content is real or fake. At first, the generator produces random output trying to mimic real images. The discriminator then analyzes them and tries to distinguish between real and generated images. Over the time, both networks improve through backpropagation, with the generator creating increasingly realistic images, while the discriminator became better at spotting fakes. This competition drives the GANs to generate highly convincing synthetic data, such as, for example, the fake photographs of individual people. In GAN, working with latent space is very important because interpolation in this multidimensional space actually allows us to adapt the output of the network after the training, adjusting individual parameters, for example, changing its values and variables, as you can see here. One of the interesting example of GANs is the portrait of Edmond de Bellamy. It was created by the generative adversarial networks, a technology developed by French art collective Obvious. Yet this portrait sold at Christie's for over $400,000, more than 40 times the original estimate. Lindsay Griffith of Christie's auction house likened the phenomenon to the invention of photography, and the market seems to be interested in art created by artificial intelligence. Another fascinating application of neural networks is artistic style transfer, where the style of one image is applied to another. Imagine turning a photograph into a painting in the styles of Picasso. This is done by leveraging activations in the network's inner layers. These activations represent the content of an image, while the correlation between them capture its style. Style transfer works as an optimization problem, where the goal is to modify the input image so that its activation resembles the original photograph, while its correlation matches the desired artistic style. By selecting different network layers, we can control which aspects of the style are transferred, from brushstrokes to colors or even structural deformations. Text-to-image generative models are opening a whole new chapter in AI. Models like DALL-E, Midjourney, or Crayon are transforming how computers interpret and visualize language. These models rely on two main components: natural language processing to understand words and a visual autoencoder to generate the images. This combination allows them to create visuals from textual descriptions. A particularly fascinating aspect is zero-shot generation, the ability to generate images of concepts the model has never seen before. This works by training the text and visual components together, enabling the model to associate words with images. However, the results depend heavily on prompt engineering, so basically how the input text is crafted. The way a prompt is written can significantly influence the final image, making text generation an art as much as a science. So here are basically a couple of the basic original images that were generated by the DALL-E Mini back in 2022. So as you can see, probably neither of these examples actually existed on the internet before. So this is the zero-shot approach that we are able to use. My favorite one is Gustav Klimt's iconic painting The Kiss, which is known for its golden hues, intricate patterns, and intimate composition. So when transformed using zero-shot diffusion models, the artwork takes on new and unexpected visual forms, demonstrating how AI can interpret classical art in an entirely novel way. So these models, without prior exposure to specific training on the painting, use their learned association between text and image to generate unique variations. The AI can reimagine the piece in a different artistic styles, altering its color palette or even reconstruct it with modern or surrealistic influences. But here we start to tackle a very important question, and that is the question of authenticity in art. Traditionally, we judge the value of art by its originality and the human experience behind it. But what happens when machines can create works that are basically of the same visual pleasing quality as the human-made pieces? Imagine standing before two paintings, one by a human, the other by AI. At first glance, they may appear equally compelling. But if you learn one was machine-generated, does that change how you perceive its authenticity? Some may argue that true art requires human intention, emotion, and cultural context. Others counter that if an AI-generated piece evokes the same feelings as human-created art, it deserves to be considered authentic. This debate intensified in 2022 when Jason Allen won a blue ribbon at the Colorado State Fair with an artwork created using Midjourney, an AI-powered tool. Many artists criticized the decision, arguing that AI-generated works lack true artistic merit. Allen, however, was absolutely transparent about his using of AI and defended his work as a new form of creative expression. With tools like DALL-E, Midjourney, or Stable Diffusion, AI is basically democratizing the art, allowing anyone to generate complex visuals with just a text prompt. While this opens up exciting creative possibilities, it also raises concerns among traditional artists, both about the ethics of AI-generated art and the impact on their profession. In this new era, we must rethink what it means to be original and how we define artistic value in a world where machines can create, inspire, and even compete with human creativity. Even the most ambitious AI-driven artistic projects, whether in music, painting, or poetry, rely primarily on the analysis of structures and patterns. While AI can produce variations that divide from tradition, these are often viewed as technical modifications rather than true creative interventions. The deeper, more critical role of AI and art to challenge conventions, offer new perspective, or actively engage with the world frequently takes a backseat to what Jana Zelinska described as a beauty taken from the crowd, a refined version of I know what I like and this is what I want to see. The term computational creativity is often used to legitimize the AI-generated works, presenting them as achievements in artistic innovation. However, as some critics argue, these creations primarily parrot the aesthetics of past masters rather than forging genuinely new artistic directions. If our role is to provoke thought and reshape how we see the world, then AI-generated simulations, no matter how convincing, may only be reinforcing existing artistic legacies rather than expanding them. So, why should we be fascinated by a world of simulation where we are merely replaced rather than challenged? You may remember the monkey selfie controversy, where a monkey took a photo of itself using photographer David Sledger's camera. This led to a legal debate over copyright. Was the photo owned by the monkey, the photographer who owned the camera, or no one at all since a non-human can't hold the copyright? This debate is even more relevant today with the rise of AI-generated art. If an AI creates a painting, a poem, or a piece of music, who is the true author? The programmer who developed the model? The user who provided the prompt? Or does the work belong to no one since AI, like the monkey, lacks legal personhood? Just like the monkey selfie case, AI-generated art challenges our traditional ideas of authorship, creativity, and ownership, raising complex legal and ethical questions in the digital era. With every new technological breakthrough in the art, there are fears that artists will be replaced. But history shows that technology and art evolved together, not in opposition. When photography was invented, many thought it would spell the end of traditional painting. Instead, it pushed artists toward a new avant-garde movement like Impressionism and Cubism. When 3D graphics emerged, some feared it would replace traditional animation, but instead it opened the door to breathtaking new worlds in cinema. Now, in the age of AI, similar concerns arise. AI can generate art, but that doesn't diminish the value of human creativity. Instead, it offers artists a powerful new tool, one that can inspire, enhance, and expand artistic possibilities in ways we never imagined. Rather than fearing AI, we should explore how it helps us push the boundaries of artistic expression. The real question now isn't whether AI can create art, but how we choose to use it. Will we see it as a threat or as an opportunity to redefine creativity? The future of art is not just about the machines, it's about the synergy between human imagination and the technological innovation. And with that, I would like to thank you.